A stranger from the stars, 3I/Atlas, the third confirmed interstellar object, is about to skim past Mars at just 0.19 astronomical units, roughly 28 million kilometers away. Every Mars orbiter is on high alert, racing to uncover its secrets. But this isn't just another comet flyby. The object glows with an unnatural emerald light, pulses in rhythmic microaccelerations, and emits carbon dioxide at levels that defy every known comet model. What is 3I/Atlas? A bizarre interstellar relic, or something engineered? As Earth slips behind the Sun, our instruments fall silent. For the next 6 hours, Mars becomes the solar system's only set of eyes. The stakes? Nothing less than rewriting what we know about alien visitors. Inside the Marvin Control Center, the Red Watch crew, NASA's contingency operators, take their stations. Their orders? Treat this like first contact. Every second counts. Backups are armed, configurations tested, commands double-checked. Mars Express, ExoMars TGO, and MAVEN are synchronized down to the millisecond. Their mission? Track, record, and survive whatever this thing unleashes. Mars Express will fire off images every few minutes, stacking exposures to capture even the faintest sign of fragmentation or course shift. TGO's spectrometers will sweep the coma for spectral lines that don't belong, while MAVEN's sensors listen for magnetic ripples or charged particle spikes, possible signs of something unnatural. The system runs like clockwork. There's no room for error, not when every other eye in the solar system is blind. As countdowns tick in every control room, blackout begins. Earth fades. Mars stands alone. But this is no ordinary comet. Since its first detection, 3I/Atlas has behaved like nothing astronomers have ever seen. Its story began far from any lab or observatory, in a small backyard in Pune, India. Amateur astronomer Priya Ralo was the first to spot something strange, a repeating light pulse, brightening and dimming in perfect rhythm. A comet shouldn't do that. Yet the pattern persisted, as precise as a heartbeat. Soon, professional arrays joined the watch. Data poured in, and the anomalies multiplied. The brightness spikes came at regular intervals, far too stable for random outgassing. Each pulse began sharply, then decayed like a machine switching on and off. As the object neared the Sun, the pattern never blurred. Whatever caused the rhythm, it was resisting solar interference. Spectroscopy deepened the mystery. Instead of water vapor, the signature of nearly every comet, 3I/Atlas emitted pure carbon dioxide at an 8:1 ratio compared to water. That's 10 times higher than any comet ever recorded. And then there was the color, a vivid emerald glow, peaking at 560 nanometers, consistent across every instrument, both orbital and ground-based. Scientists tested every known emission: C2, swan bands, carbon monoxide, nickel lines, but nothing matched the intensity or consistency of that green light. Even the nickel emission lines outshone iron by fourfold, a complete reversal of every known comet's profile. Then came the imaging data. The coma's light polarization was negative, more like that of asteroids than icy wanderers. Its dust grains moved slower, larger, and in broad, lazy arcs, as if something were releasing them in controlled bursts, not chaotic jets. Tracking data showed micro-accelerations, small, precise nudges synchronized with each pulse of light. Natural jets could never be that regular. The implication was clear. Something, or someone, was controlling this motion. No single anomaly could prove that. But together they painted a portrait of a visitor that didn't fit any known category. As scientists raced to explain it, 4 main theories emerged. Theory 1. extreme chemistry. Perhaps 3. I/Atlas was born in the coldest reaches of interstellar space, far from any star. There, water freezes out first, leaving exotic ices, carbon dioxide, carbon monoxide, even rarer compounds. This could explain the chemical imbalance, but not the rhythmic pulses. Theory 2. Volatile pockets. Maybe it's structural. Layers of trapped gas erupting in sequence as sunlight warms the crust. That could produce repeating flares, but the precision of the pulses strains belief. Theory 3. Dust dynamics. The slow-moving, emerald-glowing grains could be made of carbon-rich compounds, responding to Mars's magnetic field in ways not yet modelled. But again, nothing explains why the pulses are so exact. Theory 4. Unknown. Physics. Maybe we're simply seeing the limits of our models. With only 2 previous interstellar visitors, Oumuamua and 2 I/Borisov, our understanding of such objects is primitive. Perhaps these synchronized pulses are a natural phenomenon we've never encountered before. But that final theory comes with an unspoken possibility that something else might be at play. Back at Mars, every orbiter focuses on a different slice of the mystery. MAVEN's ultraviolet spectrograph scans for faint emissions, searching for fragmentation trails or ionization bursts. Its magnetometers record every tiny ripple in Mars's ionosphere, the kind that could reveal plasma interaction from an artificial source. Mars Express, equipped with the visual monitoring camera and SPICAM spectrometer, hunts for direct visual proof, splitting, shape-shifting, or unexpected emissions. And ExoMars TGO, with its NOMAD and ACS spectrometers, measures isotopic ratios, searching for molecules that don't exist in the solar system. Even on the surface, Perseverance and Zhurong rovers listen for indirect clues: dust disturbances, auroras, or atmospheric flashes triggered by interaction. Every reading is cross-referenced across spacecraft. No single anomaly counts unless confirmed by another. Only converging evidence can unlock the extraordinary. Every byte of data is duplicated, time-stamped, and mirrored across NASA and ESA ground stations. Nothing is left to chance. Even a tiny transmission glitch could be mistaken for alien interference. So, verification is absolute. Citizen astronomers join in too. From India to Arizona, small observatories upload their own readings to shared networks. In this decentralized web, a single backyard alert could trigger a global review within minutes. The system isn't just for science, it's for trust. If something extraordinary happens, no single agency controls the narrative. Every reading will be public. Every anomaly open to scrutiny. Inside the RedWatch control room, the final decision framework stands ready. A flowchart that determines how humanity responds. 3 possible verdicts. Conservative. Every anomaly explained by rare natural processes. Hazardous. The object fragments or alters course, threatening orbiters. Extraordinary. At least 2 statistically verified anomalies defy known physics. Synchronized pulses and microaccelerations confirmed independently. Only then does the label "engineered" even enter discussion. Every operator knows what's at stake. For these 6 hours, humanity's understanding of the universe balances on a few spacecraft orbiting a dead world. And this time, secrecy isn't an option. Under new transparency protocols, all interstellar flyby data, raw and annotated, must go public within hours, not months. NASA, ESA, and JAXA have built mirrored archives for open access. AI filters flag outliers for instant review. Amateur networks are now part of the official chain of discovery. What starts in a backyard telescope could trigger a full agency alert. Planetary protection officers, meanwhile, log every particle sample, every dust grain, under digital custody. Proof that any organic compound found later truly came from beyond. This isn't just about 3I/Atlas. It's about building a global system for the next visitor, one that ensures truth, transparency, and scientific integrity in the face of the unknown. On October 3rd, 2025, as 3I/Atlas swept past Mars, 3 orbiters and 2 rovers recorded 40 hours of high-cadence data. The results stunned the world. The object's emerald glow, its carbon dioxide-rich chemistry, and its perfectly synchronized light pulses remain without a definitive explanation. Every natural theory explains some of it, but never all. The mystery endures. The raw data is now public, open for anyone to analyze. Some call it the most important astronomical encounter since Oumuamua. Others whisper a different word: contact. But one fact is beyond debate. The Mars flyby of 3I/ATLAS has forever changed how we prepare for and talk about visitors from beyond our sun.